equals Z11I1, Z12I2, V2 equals Z21I1, Z22I2. There's your first two equations that you're always going to use. So this one here gives you two equations. Over here you're going to have plus one equation, and over here you're going to have plus one equation. It just so happens that the plus one equation over here is a little bit trivial. Alright, I wonder if we should plug in my values. I think we're going to talk procedure more than component values, because even if we do that, there's a high probability of making lots of mistakes that we do in applied. So let's go back over here. So let's look at what equations do I have to play with here. The first one I've got is V1 equals Z11I1 plus Z12I2. V2 equals Z21I1 plus Z22I2. Now I got to come up with a couple other equations. I said I can get one equation from the left, one equation from the right. So let's do that. The equation on the left here, if I want to know the current going in, so let's figure out I1 and here's the V in here. So what is I1? Let's figure out I1 and I2. Looking from the outside of the circuit here. Okay. So I can get here that I1 equals V in minus V1. So this voltage minus this voltage divided by that resistor. And then I could say, I could do a similar thing for I2, but I don't have a voltage source there. So all I'm going to end up with here is that I2 is equal to, so if I look at the current going through that resistor, what's the current through that resistor? It's just V out over RL, right? But I2 is referenced in the other direction, so it's going to be negative V out over RL. So I2 is going to be negative V out over RL. And I can immediately see something here too. I can get rid of V out. That'll make my life easier as well. So let me just count some things here. So I can get rid of I1 up here. I can get rid of I2 in these equations. So we've got rid of I1, we've got rid of I2. Now we've got two equations and four unknowns. So that's a bit of a problem, right? So we need some more equations here. One of the most obvious is that V out is equal to V2, right? I would say pay attention to what we're doing here, because this is the same for any loaded matrix. Now it might be set up different. This might be an A, this might be a Y, whatever. You're still going to have two equations here. You're still going to have one equation over here. You're still going to have one equation over here. If it's just a resistor connected over here, your output voltage is V2. And they might just on the test say V2. They might not say V out. So that just makes your life easier if you just say V2. So I'm immediately going to make that substitution and just say that this equals V2, negative V2 over RL. So the way that I would go about solving this is I'm going to sub this one into both. I'm going to sub this one into both. And now I've got two equations with three unknowns. I've got a V in, a V1, and a V2. And so what I'm looking for, AV, is equal to V2 over V in, right? Because remember we said that V out is the same as V2. So that's sufficient to solve the problem. I know I've got enough stuff. I've got two equations, three unknowns, and I'm going to have this divided by that, so I can actually rearrange my equation to do that. So let's start doing this here. We may not actually work through all the payment stuff that my computer did for me. So here's the first thing I would do. I'd say V1 equals Z11 times V in minus V1 over RS. Right, and then plus Z12. And at some point maybe we'll just sub in some very easy numbers just to see what it looks like. Z12, let's just say minus Z12 times V2 over RL. So I'm getting rid of my curves here. Equals Z21 times Vn minus V1 over Rs minus Z22 times V2 over RL. So now I need to get rid of V1, right? So what I would do is, let's number these here. Because I only want to be left with a V2 and a Vn, right? And then I can rearrange that to get that fraction out here. So what I would do is rearrange probably number 2 to get V1. So let's do that. So we'll say rearrange 1 to get V1. The reason I picked that one is there's only one V1 up here, but I've got another one over here which would require more manipulation. So let's see how fast this is, and we may just start putting in numbers if this gets really ugly. So we've got Z21 times Vn minus V1, should put the Rs over here, equals V2 plus Z22 V2 over RL. Okay, so that's not too bad. And we get Vn minus V1 equals V2 times 1 plus Z22 over RL times, I'm going to bring this over, Rs over Z21. So I can get V1 equals Vn minus V2 times 1 plus Z22 over RL times Rs over Z21. Okay, so I have the ability now to get rid of V1. So let's call this equation 3. I think at this point the learning about circuits has kind of stopped and the learning about algebra has begun, so we might skip a step to get to the final answer. So here's what I would do. I would say equation 3 goes into equation 1, gives you an equation 4 that's in terms of V in and V2. So everything at this point is just algebra. I'm just rearranging equations. And then what you can do is say, rearrange 4 to get, and you'll see why I wanted to skip some steps here. AV equals V2 over VI equals Z21 RL over RL RS plus Z11 RL plus, this is where having numbers have made our life a lot easier. Z22 RS plus Z22 Z11 minus Z21 Z12. So this is what you'd end up with if you went through those last couple steps. If this was numeric, we would have much simpler equations to deal with, and we probably could have done it. I don't want to sub in numbers right now on the fly because, like I said, chances are I'm going to make mistakes on the board just putting actual numbers in. Anyways, the whole gist of it isn't so much the algebraic manipulation part as the procedure for how you get your equations. Here's how you get your equations. I'm going to go back, point back up there. You will always get 2 equations from your 2-port matrix, from your 2-port network, from that matrix equation, which will most likely be given to you because it was given to you on the previous final. Okay? You will get an additional equation on your input side, an additional equation on your output side that you can, and generally what you do is you express the currents in terms of the voltage that you're looking for. That will let you get your I1 and your I2. You can then rearrange them to get your output voltage over your input voltage. So that's the general procedure once you have that. So I think we've completely exhausted the discussion on 2-port networks. Are we okay if we move on? Any pressing questions? Okay. Diodes. Diodes are not as hard as I think people think that they might be. I would not focus on learning iterative methods. I said this at the beginning, but I don't think everyone was here. Iterative methods are a thing that a computer should do for you, that you should understand why it's doing it.